So guys, as you can see, we are getting our values here from this potentiometer. If I move the knob of this potentiometer, see, the values start to decrease. The more I move it, the more it is decreasing. See, it is going down, and now once I reach the bottom, it becomes like 4, 5 or whatever it is. Then if I go in the opposite direction, it starts to increase. So this means the potentiometer is sending the ADC values, and 10 bit is the ADC. So it will be maximum 1023. See, I move it, and at the maximum, it's like 1023 max. So let me show you the code. So here in the code, you can see what is happening here is that we have this variable which will store the value coming from the sensor. We initialize the ADC pin for the potentiometer, UART port for the USB to TTL device. Then we read the value from the sensor, then we convert this to a string, and then we send the string value to our computer through the serial terminal. That's simple as that. So this coding gives us this result. So hello guys, welcome to learning microcontrollers. In this lecture, I'm going to show you how you can interface a slide potentiometer with a PIC16F877A microcontroller. And then we are going to use a USB to TTL device to send the output to the computer for analysis. So let's get started. So guys, this over here is the slide potentiometer. They come in various shapes and sizes in the market. I'm going to use this one. I have this one. So this is our PIC16F877A microcontroller having 40 pins. It's a DIP vision, and this over here is a slide potentiometer. As you can see at the back side, you can see 4 pins on the top, 2 pins at the bottom. See, only these pins matter, this and these 4 pins. So let me show you out of these 6 pins, only 3 will be used by our microcontroller. Rest of the 3 you can leave them not connected. So the bottom right one, the top rightmost, and the second from the right if you hold it like this. These are the 3 pins we are going to use. The bottom right is the VCC, the right extreme right on the top if you hold it like this is the ground, and the second from the right on the top is the ADC pin. And rest of these 3 pins, the 2 on the left side, 2 of the 4 pins on the left side of the top, these 2, and the one at the bottom left, leave them not connected. So these are not connected pins, the orange ones. So right now what I can do is that first we will connect them. So we connect the ground pin directly to the ground of the PIC like this. Then guys, we will connect the VCC pin to the VCC pin of the PIC like this. And for the ADC pin, you can use any ADC pin of the PIC. I'm going to use the pin number A0 like this. In this way, our potentiometer is connected. Now guys, to display the output, I'm going to use a CH340 USB to TTL device. You can use any other USB to TTL device as well, like FT232, CP212 or any other. Remember, every USB to TTL device have TX, RX and ground pins. As you can see, it is already labeled. I label it again. Topmost is the 5 volt, then VCC 3.3 volt, TX, RX and ground. We only need 3 pins, TX, RX and ground, to connect it with the PIC. So what I do is that I connect the ground pin directly to the ground of the PIC like this. And for the RX pin, connected to the TX pin of the PIC, and the TX pin of the PIC's UART port is pin number C6 or pin number 25. And for the TX pin of the USB to TTL device, connected to the RX pin of the PIC, that is pin number 26 like this. In this way, our USB to TTL device is connected, our potentiometer is connected. Now let me introduce you to the hardware before we move on to the programming. So guys, this over here is our hardware. As you can see, this is the USB to TTL device. I will plug it into the computer, and this is our potentiometer I am talking about. See, it is the same as shown in the photo as well, and from the back you can see that the wiring is also the same. So let me show you the pins. See that 2 pins on the right, this one and this one are connected. Left 2 pins, I left them untouched. See, they are not connected. And from the bottom on the only the right pin is connected. This is like having 2 channels. If you use these 3 pins, you can also use it, but that will be like opposite. You slide this way and the values will go opposite. If it is increasing in this configuration at this end, then it will be decreasing here. If you use the other channel, then it will increase. So that's not an issue. Just connected in this way. Only 3 pins of our potentiometers are required. Now behind you can see is the PIC16F877A, and the connection is as shown in the presentation. Rest is just a trainer board, so don't worry about it. Now let's move on to the MikroC to start the programming. So guys, this over here is the MikroC for PIC version 7.6.0. I have a video on this as well, you can check it, in which I have shown you how you can download and install the latest MikroC for PIC version for free from official website. Please go through that. Click on new. Okay, let me show you. Click on new, file, new project. This window pops up, new project wizard. Click on Rex, write the name of the project. I write linear pot tutorial by learning microcontrollers. Okay, this is the name I wrote. You can write any name you want. And the microcontroller we are going to use is PIC16F877A, and the crystal we have is 20 megahertz. This is the crystal connected to pin number 13 and 14 pin of your PIC16F877A. Now click on next and finish. So this window pops up. What you do is that press Ctrl S. First of all, save your work like this. Now first we will need an ADC pin, because our potentiometer will give an ADC output. To read the potentiometer, we initialize the ADC pins of the PIC. So go to the right in the MikroE libraries, expand it, expand the system library. Here you have the ADC, check mark this and expand it. Here you have this command ADC I90. Double click on this and go in the example. You have this command ADC initialize, copy it, paste it here. Now this command initialize all the ADC pins of your PIC16F877A. After using this command, I suggest you give some initialization delay. Not necessary, but I always suggest you give it in the one time loop. So I give an initialization delay of 20 millisecond. Now guys, the next thing is we have a USB to TTL device which works on the UART protocol. So here again, go to the libraries, and here you have UART protocol library. Check mark this, expand this. Now here you have this command UART1 I90. Double click on it. And in the example here you have this command UART1 initialize 9600. Go back, paste it in the one time loop. Okay, it sometimes asks for saving again. That's why I told you to save in start. So just select the folder where you want to save. It pops up on auto. Okay, here I would like to save the file. Okay, again paste the command. This is UART1 I90 9600. Now this is the syntax to the command which will initialize the UART port for USB to TTL device, and this is the baud rate. Whatever baud rate you set here, you have to set on the serial terminal as well when you read the data or send the data using the USB to TTL device. Now the UART port is initialized. We gave some initialization delay again for this command as well. Now our ADC pin is initialized for the potentiometer, and our UART port is initialized for the USB to TTL device, and we don't have anything else. So we just move on to the forever loop now. I write here while one forever loop starts here, ends here. And what I do is that first of all we need to read the value coming from the potentiometer. For this, go to the right in the ADC library. This is the ADC library. Here you have this command ADC read. Go down, this is the command, just copy it and paste it here, this command. Now guys, here this is the integer or a variable, a float or a short or a long, whatever you prefer, which will store the data coming from the sensor port. And this is the ADC read command syntax, and this is the channel. So this command is like you have the variable to store the coming data. This is the syntax ADC read, and this is a channel. Right now, as shown in the presentation, we are using pin number A0, which is channel 0. A1 is channel 1, A2 is channel 2. So A0 is a channel 0 out of the 9 channel of PIC16F877A. So data will be coming from 0. Now for this, we write any variable here. First of all, we initialize it, go above the void main. I will take an integer because I don't want the float. Integer, I take Lpot, means linear potentiometer. So this is the variable, we paste it here. So this integer will store the data coming from the sensor. Give some initialization delay, not necessary, but I always suggest you give it here, a 20 millisecond delay. Okay, that's all. Now the data will be constantly read using this command, and now we want to display this data on our computer screen for analysis, that what is the data we are getting. So is our potentiometer is working or not. So for that, what I do is that I will convert this integer to a string, because we cannot send directly the integers to our computer screen for display purpose. To convert this to a string, go to the right. Here you have this library called conversion. Check mark this, go to the conversion library. Here you have this command called integer to string. This command will convert this integer value to a string to be displayed on the LCD or over the USB to TTL device to the computer. Now, this command over here, first of all write the integer here which you need to convert this one. Now, you will need a char in which the data will be converted. Now, go here, make an array of char which is a string. So, I write Lpot 1 and 8 is the length. So, it is an 8-bit array. So, an array of char is also a string, remember that it is an array of char having 9 characters, sorry. So, now this will be whatever is the integer here will be converted into a string and will be stored in this variable over here. Now, we can send this variable over the UART channel. Now, to send this, also give some initialization delay here, not necessary, but I always suggest you give it. Now, go to the right, go to the UART library. Now, we want to send this text to the computer using the USB TTL device. Check mark this command UART write text and go to the example here that pops up when you double click it, this command UART1 write text output. Go back, paste it here, inside it write whatever the text you want to send. I want to send this text. Now, this will be sent as soon as this command is executed, whatever is in this will be sent to the computer. Now, once the data is received, I want this to be like going to the next line. I do not want the data to be constantly displayed in the same line. So, it will be very confusing to read. So, to make sure that the data do not goes to the same line, I write this command /or/n. This command makes sure that your data will not go to the next line. Let me verify this command as well from my other code. Okay, it is /or/n. That's perfect. Okay, this is just like in Arduino, you use this command serial dot print, and if you add ln, it moves to the next line. If you don't add ln, it will remain in the same line. So, this is like this thing is equal to like ln. So, I can call it ln is equal to this. So, it means next line. So, that is why I wrote this. So, once the data is written, then it will move to the next line. So, next data after the repeat will be written in the next line. So, now we give some delay because data will be too fast to read. I give a delay of like 250 to make sure that I do not receive data at too fast rate to be able to read on the terminal. So, this is it. I built the code. Code is built, no error. Okay. Now, go to the PIC16 programmer tool. So, we can burn it. Okay, this is our PIC16 programmer tool. Select the device, PIC16F877A is the one I am using. Click on File, Import, and this is the hex file we just created. Click on Write. I also have a tutorial video on this as well, how to download and install this PIC16 programmer tool. Please go through that as well. Okay, now let us go to the hardware. Okay, let us wait. Okay, the data is written. I power up the circuit using the PIC16. Click on On. Okay, circuit is powered up. So, it is not connected into the computer. So, let me connect it into the computer and see what we are getting. Okay, see something is being sent, the blue LED. Now, let us connect it to the computer to see what is being sent. Okay, it is connected. I have connected it here. You can see that it is connected. Okay, now it is connected. Let us go to the serial terminal. Go to your MikroC for PIC software. Here you have this tools. In the tools, go for this USART terminal. Go there, select the COM port. Once you install the driver, it will assign a COM to your device. Mine is COM 11. 9600 is the baud rate we set in the programming. Click on connect. Okay. We are getting this data. Okay, let me check. We are not moving to the next line. There is some mistake in the coding. Okay, /or/n. This didn't work. Let me check. Okay, I wrote the opposite slash. I think I wrote the reverse slash. So, this is the forward slash. So, sorry for that. Okay, let us rebuild the code. Let it write. Then again go back to the serial terminal. Okay, the code is written. Go to the serial terminal, USART terminal here. Clear the screen. Connect. Okay, that was the backslash I wrote. It is forward slash. See, now it is coming to the next line, and we are getting 491. So, let us move the knob of the potentiometer and see does this data changes or not. Okay, let me place it somewhere where you can see it as well, both things. So I want you to see both. Let me move the screen. Okay, let's see what we can do. Okay, here is our potentiometer. On the right side, you can see I am holding it like this. There. Now we are getting 490, 491, 492 values. You can see I move it. See, it changes to 583, 582. Now I move it further, it goes up. I move it further, goes up and up. See, the more I move it, now it is the maximum because it's a 10-bit ADC. So maximum value will be this. Okay, let me zoom out a bit because it's difficult to see. Okay, now it seems fine. Now see, it's now at maximum. See, this is the max. Now I move it back. See, it's changing again. It is now lowering down. See, that is what is happening. See, it is lowering down. The way I move it back, it goes down, down, down to 0. See, it's 0, about 0 here. Now again, if I move it on the upper side, you will see the value starts to change. So I move it. See, the value is increasing, increasing. See, the ADC value is increasing. Now it's at here. I leave it. It remains here where I have left it. So if I move it further, it will further increase the value. See. So guys, this is how it's gonna work. So it is very simple to use, easy to program. So guys, you can make tons of projects out of it. So I hope you guys learned something from this lecture. Thank you very much for your time, guys. We'll see you in the next lecture. Goodbye until then.